Okay, a 1580 kilogram car that's going to be our mass, right? Is traveling with a speed of 15 meters per second. I'm going to call that let's call it V1. What is the magnitude of the horizontal net force? Net force that is required to bring the car to a halt in a distance of 50 meters. So we have a couple things going on, and we want our picture. Here is our ground, and we have a car with a mass that is traveling this way with V1. And eventually, in 50 meters, we are told that it stops. So I'm going to say that V2, I'm going to assign it V2, but we know that is 0, right? And then we know that this distance here, it was 50 meters. So, like I said, velocity changes when there is acceleration. If we were going right and we stopped eventually, we obviously must have had some acceleration going to the opposite direction that we were moving, right? And that is what, yeah, so that is, yeah, so there's an acceleration, but ultimately we're asked, what is the force? This is what our final answer, that is what we are looking for. Okay, so I'm gonna organize what we know. We know mass. We know V1. We know that V2 is 0. We know the distance that we traveled. Is that it? We don't know the acceleration that was present to make us stop, and we don't know what the force was. And now step 3, let's think about equations. This is a combination of kinematics and F equals ma. I know since you guys are still new to these equations, kind of like figuring out that you need to use both of them to figure out this problem is difficult. It's hard to catch that. It comes with practice. So I just want you guys to just listen and follow and practice, repeat, do this problem 3 times, and then you guys will be able to understand. So our kinematics equations, V final. I'm not going to really explain it because I am in a hurry here. So these were our kinematics, right? 1, 2, and 3. We've seen these many times now. And we are asked to find the force. We have the force, mass, and acceleration. That sounds like Newton's law. So these are going to be our equations that we're going to consider. Now let's go on to step 4 of actually solving this problem. Ultimately, our goal is to plug in to equation number 4. We're asked to find F. So we need mass and acceleration. We already have mass that was given to us, but we don't know what the acceleration was. The acceleration that made us stop from our initial point to our final point. We don't know that. So that is where our kinematics equations come in. We should be able to find out. We have, we're looking for acceleration. All of them have acceleration. Okay, let's just start evaluating them. V final, we know. V initial, we know. Acceleration, that's what we're looking for. Time, we don't know how long it took to get from initial to final, so we're not going to look at number one. Number two, displacement, we do know it was 50 meters. The initial, we do know. Time, again, we don't know. So most likely it's going to be number three. So I am going to do this. And we're going to zoom in here. So displacement equals, oh, oops, that's not the right equation. We're looking at number three, V final squared minus V initial squared equals 2AX. And our problem, that was V2 squared, right? That was V2. Yep, V2 minus V1 squared equals 2AX. We want to find A. So I'm going to divide both sides by 2x and flip it. I hope that's not skipping too many steps, algebra steps for you. Did I say divide by 2a? I hope I didn't. I meant by 2x. We want A. V2 squared minus V1 squared all over 2x. And let's put in our numbers. V2, that was our final velocity, right? That was 0. So 0 squared minus V1. Our initial velocity was 15 meters per squared. So 15 squared over 2x, the displacement, the distance we traveled, which was 50 meters. And put that in your calculator, and I am going to, oh, low battery. I got negative 2.25. Let me check if that is correct. I don't want to continue if it's not. What number is this? Is this 7? Yep. Yeah, that is our acceleration. Awesome. So we found our acceleration right here. And now let's just solve for F. F equals ma. Our mass was 1580, and our acceleration, we just found that right here, was negative 2.25. Put that in your calculator. And you get negative 3560 newtons. Okay, the answer though. It is asking us, what is the magnitude? Magnitude is just asking how much. It's not asking for the direction. Remember, this negative means that just indicates our direction. So when we're asked for magnitude, just drop the sign. So our final answer should be this